Hello guys, welcome back. I am going to discuss writing equations of lines with you. And this is a continuation of the previous video we did on graphing linear equations. So now we're going to be writing the linear equations, okay? So when it comes to writing linear equations, guys, you will need typically two components, okay, when you're writing the equation of lines. And so the two components include the slope, which we use the letter M for, and then number two, a point, which we identify as x1, y1, x1, y1. Now, if you have both of those components, what you are to do for step number one is to go ahead and substitute the point and the slope, the point and the slope, into the point slope formula. The point slope formula, guys, is just like what it sounds. So the point slope form or formula is y minus y1 equals to m times x minus x1. Now, I want to highlight some things on here. So remember, you need a slope, you need a point in order to be able to write the equation. So when you're substituting in the point and the slope into the point slope formula, be careful. You are going to substitute the slope in for m. The x1 and y1, you're going to substitute the values in there from the point into the equation. However, the x and y variable, this right here and this over here, will remain, guys, as the variables of the equation, okay? So you are only going to substitute values in for y1, m, and x1. Now, that's the first step. And be careful when you're doing these problems online, because many of the problems will ask for the point slope form. So make sure you read the direction. Now, step two, you want to go ahead and solve for y to rewrite the equation. You're going to rewrite the equation and slope intercept form. Now, for the slope intercept form, guys, we've looked at it already, because it's the same form we use to graph the equations of lines. And so y equal mx plus b is the slope intercept form. Now, additionally, sometimes some of these problems will ask you to write the equations in function notation. Now, remember, with function notation, y is being replaced with f of x. So essentially, in function notation, you have the same equation. The only difference is y has been replaced with f of x, guys, okay? So that is the slope intercept form or function notation. Now, every once in a while, they may ask you to transform the equation to standard form. They may ask for standard form. And if they ask for standard form is ax plus by equals to c. As an x and y are on one side, it doesn't matter left or right. And of course, the constant, the c value, is on the right side, okay? Now, in writing standard form, guys, be careful with this. No fractions in standard form are allowed. No fractions, okay? And every once in a while, in some textbooks and some tests that you're actually taking, the standardized test, the a value cannot be a negative value. So be careful with that. At least for sure, no fractions. But the leading coefficient being a negative, it's okay, guys, okay? Now, let me go ahead and give you guys some thoughts to remember, okay? Here are some exceptions. Remember, if the slope, okay, so this is the first thing, if the slope is equal to 0, remember, a 0 slope means there's no vertical change, there's only horizontal change, then what you have is that you have a horizontal line. The line is horizontal when you graph it. So if it's going to be a horizontal line, when you graph it like this, so what is the equation? The equation will be in the form of y equals to whatever the y value is. Y equals to whatever the y value is, okay? So if the slope is 0, guys, automatically you're going to have an equation in form of y equals to some constant, okay? Now, additionally, if the slope is undefined, all right, if it's undefined, then the line, oops, I didn't write then, I said they, okay? Then the line is vertical. It's vertical. It goes up and down. So which means you have vertical change, but no horizontal change, okay? It's vertical. And so the equation of that line that is only going to intersect the x-axis is going to be in the form of x equals to some value. So be careful with this one, guys, okay? Sometimes they will give you a slope of 0, so you'll end up with a horizontal line that has an equation of y equals to some number. And then on the other hand, you will be given a slope that's undefined, which reflects a vertical line, so the equation is going to be in the form of x equals to something, all right? Now, last thing before I start looking at some examples with you guys, if you are given 2 points, okay, I am going to do some examples with you guys in a minute, okay? If you are given 2 points, remember you need 2 components to write the equation of a line. If you're given 2 points, you're missing a slope. So the first thing you have to do is find the slope first, and then use one of the points, and then write your equation. Given 2 points, find the slope first, guys, okay? Now, you know what, let me highlight this. I'm gonna mention this. By the way, the slope formula, y2 minus y1 over x2 minus x1 is the formula we're using. But remember, you can do this intuitively, organically, guys. You can do it organically without having to memorize a formula, and I mentioned that in the last video. Now, I feel like I need to mention this before I start doing the examples: parallel lines and perpendicular lines. So when we talk about parallel lines, we're looking at, by the way, this is the symbol for parallel lines, okay? This represents 2 lines that they're of course drawn in the same plane. 2 lines drawn in the same plane that will never intersect. 2 lines drawn in the same plane that will never intersect. So since they are 2 parallel lines, let's say we have line number 1 here, okay? Notice line number 1 is rising to the right, so this one is going to have a positive slope. So if the other one is going to be parallel to it, it also has to rise to the right, so it also has to have a positive slope. And so in order to maintain that these 2 lines are parallel and they will never intersect, they must have the same slope, as in the same rise over run. So 2 parallel lines, guys, will always have the exact same slopes, okay? So now, if I were to give you an example like this, let's say line number 1 had a slope of 3/4, and I were to ask you if line number 2 is parallel to line number 1, what would be the slope of line number 2? Line number 2 would have the exact same slope, 3/4. Yep, just like that, okay? Now, here comes another one, guys. This one is about the perpendicular lines. When we talk about the perpendicular lines, which you guys, I'm sure, looked at in geometry quite a bit, the symbol we use for this looks like an upside down capital T, okay? And so for the perpendicular lines, we're looking at 2 lines drawn in the same plane, which intersect at a 90-degree angle. All right, so let me go ahead and do a little sketch over here so you guys can see it. let's say I have line number 1 here. That's my line number 1, okay? And I want a line that is perpendicular to line number 1. I first, by the way, this is a positive slope graph. First, I have to draw it in the opposite direction. Did you guys hear that? The opposite direction. So if the first one was positive, then that means that the other one is going to have to be a negative. So the first thing you should notice is that the signs are different. One's positive, one's negative. Additionally, guys, in order for us to get to this 90-degree angle, you have to rotate the line number 1, 90 degrees to get to line number 2. So essentially, if line 1 had a slope of A over B, line 2 will have a slope of, because you are going to go ahead and rotate this 90 degrees, the slope is going to reciprocate. So it's going to become B over A. And of course, don't forget about the fact that the signs are different, guys. So that was a lot that was said there, and that's a lot of writing because, you know, my screen is limited. But the bottom line is this, guys. When we talk about two perpendicular lines, we have opposite. Here, let me use a different color. Opposite perpendicular lines have opposite reciprocal slopes. Opposite reciprocal slopes. Okay. So what in the world am I talking about? Let's say line number 1, guys, had a slope of 3 over 4. I'm just making this up as I go along. Line number 2 would have the opposite reciprocal slope, so that would be a negative 4 over 3. So you want to reciprocate it and do the opposite reciprocal slope. So 2 things. By the way, you can check these, guys. How do you check them? If you multiply the 2 slopes together, it must give you, the product must be -1. So if you multiply 3/4 times -4/3, it must give you -1. So that's how you, that's one way to verify that 2 lines are perpendicular. If you can multiply the 2 slopes and it gives you the -1 value, absolutely, okay? The product turns out to be a -1, absolutely, guys. So what I'm gonna do now is run through a few examples, and then I will save the rest of the examples, the remaining examples for class, okay? So I'm not going to do a whole lot. Let me start with something very basic. And for this first one, it says that the line goes through the point -3, 5, and it has a slope of 3. Remember, we're writing the equation of lines, guys. So first, I am going to go to the point slope formula, and I am going to substitute these values in. Remember, we're only plugging in values for x1, y1, and m. Now, m is 3. This represents x1, this represents y1. That's your point, so it's x1, y1. So now, guys, we go into the formula. We substitute 5 in for y1. Substitute 3 in for the slope. Okay, my pen is not writing, guys. What's up with this pen here? Okay, it's not writing. Okay, there we go. And then x minus, now be careful with this, guys, because the x value is a negative. So when you do this, you'll end up with 3 times x plus 3. So for this one right here, you want to go ahead and leave it like this in point slope form. That's the point slope. You're good. That's point slope if that's what you're looking for. But if they want you to do slope intercept form, then you want to go ahead and solve for y. How do you solve for y? Well, we're going to distribute the 3. So we get y minus 5 is equal to 3x plus 9. You add 5 to both sides. So you end up with y equaling to, this cancels out, 3x plus 14. And just like that, guys, you have your slope intercept form. But what if they wanted in function notation? Function notation. So in function notation, you're just going to replace the y with f of x. So your function notation would be f of x equals to 3x plus 14, and that's it. Yeah. Now, additionally, guys, they could ask you, well, what is the standard form of this equation? The standard form of the equation. If they ask for standard form, as an ax plus by equals to c. So on this one right here, you want to go ahead and take that equation, y equals to 3x plus 14, and rewrite it in standard form by moving the 3x over to the left side, So you get negative 3x plus y is equal to 14. And guys, just like that, you have your standard form and you're done. Okay? So not too bad. Okay? Now let me go ahead and do a second example. This next one right here, guys, the slope is negative 2/3 and the graph goes through the point 0, 2. Now remember in the last video we talked about the y-intercept. Whenever x is 0, you've got a y-intercept, guys. Whenever x is 0, you got a y-intercept, because where do you go to find 0, 2? Hello, along the y-axis, exactly on the y-axis. So that's a y-intercept, guys. So for this one, if they were to just ask you to write the equation in slope-intercept form, if they just ask you to write the equation in slope-intercept form, you don't even have to go through the point slope. You can go straight to the slope-intercept form, y equal mx plus b, and substitute the values in. So your m value is negative 2/3, your b value is 2. So your equation would be y equals to negative 2/3 x plus 2. And just like that, you're done. That is what we call the slope-intercept form. You didn't have to do much work for this one because they gave you the y-intercept, guys, okay? Now, the other reason why I wanted to do this one with you is to write it in standard form, guys. So let's do this in standard form. So if we wanted to take that little equation here and rewrite it in standard form, listen, this one requires work. Why? Because there's a fraction in there, okay? And remember, standard form, you're not allowed to have any fractions in the equation. So the first step, by the way, guys, it's up to you what you choose to do first. You can multiply everything by 3, or you can go ahead and move the negative 2/3 over first and then multiply everything by 3. It's up to you. It doesn't matter. So I moved the 2/3 over to the left, so it's now a positive, okay? So now I am going to go ahead and eliminate the fraction. Now remember, how do we eliminate a fraction? We multiply everything by the LCD. There's only one denominator in this case, so the LCD for this one is going to be 3. We're going to multiply everything by 3. So if you take 3 multiplied by 2/3, the fraction cancels out, leaving you with 2x. 3 times y is 3y, and then 3 times 4 gives me 12. So there's your standard form, guys. That's it. Not bad. Okay, so here's a couple more problems, and then I will be done, okay? So here's an ambiguous one, guys. This time it's saying, write the equation of a line with an undefined slope, all right? And it goes through the point 5, 4. Now, when the slope is undefined, as I mentioned earlier, you have a vertical line. Which axis is a vertical line intersect? It intersects the x-axis. So you're going to end up with an equation in the form of x equals 2, okay? Whatever the x value is of the point. So if you were to draw the line through 5, 4, where would the graph intersect the x-axis at? It would intersect the x-axis at x equals to 5. And that's it, guys. That's your vertical line, the equation of your vertical line. On the other hand, if they tell you, oh, you have a horizontal line, and you got to write the equation of the horizontal line that goes through the point through -6, 2. Now, if it's a horizontal line, remember, it intersects the y-axis. So if it's going through this point right here, where is it going to intersect the y-axis at? Y equals to 2. And that's it. That's your equation, guys. I think what I'm going to do is to stop here and then save the other questions for when we do get to class. And then we can elaborate on whatever questions you might have. But for now, guys, I'm basically done. Okay? Bye. Until next time, everybody.